NASA's Parker Solar Probe. A spacecraft has gotten close enough to touch the Sun for the first time in history. Hello guys, welcome to our YouTube channel. NASA's Parker Solar Probe has gone through the corona, the Sun's upper atmosphere, sampling particles and measuring magnetic fields in this dynamic environment. Today, we look at the current achievement of NASA's Parker Solar Probe. The current accomplishment represents a significant advancement for the Parker Solar Probe and a great leap forward for solar science. Touching the Sun allows scientists to learn more about our closest star and its impact on the solar, just as landing on the Moon helped them learn more about how it was formed. The results of this achievement were unveiled at a press conference at the American Geophysical Union's autumn meeting in New Orleans on Tuesday and have been approved for publication in Physical Review Letters and the Astrophysical Journal. This is the very first time a spacecraft has entered the Sun's atmosphere. It's a watershed moment in solar research. The Parker Solar Probe, constructed and run by the Johns Hopkins Applied Physics Laboratory, is making discoveries that other spacecraft couldn't observe because they were too far away, including from within the solar wind, a fast-moving stream of particles from the Sun that can affect Earth. Switchbacks, which are dramatic magnetic zigzag formations in the solar wind, were discovered in abundance quite close to the Sun by the Parker Solar Probe in 2019. Parker Solar Probe has now found one site where those features originate, the solar surface, after halving its distance from the Sun since then. The first flyby into the corona and subsequent flybys will reveal information on processes that are too difficult to examine from afar. Parker Solar Probe is already detecting circumstances in the corona that have never been observed before due to its proximity to the Sun. Magnetic field data, solar wind data, and visual evidence in white light photos all point to being in the corona. For the first time, spacecraft may be spotted flying through coronal structures that can be viewed from Earth during a total solar eclipse. Parker Solar Probe was founded in 2018 to investigate the secrets of the Sun by traveling closer to it than any previous mission. It was built to resist some of the harshest conditions in the solar system. The Sun, unlike Earth, lacks a solid surface, but it does have a superheated atmosphere made up of material held together by gravity and magnetic forces. As that material is pushed out from the Sun by increased heat and pressure, gravitational forces and magnetic fields become insufficient to retain it. The very end of the solar atmosphere and the start of the solar wind are marked by the Alfvén critical surface. Solar material without energy to pass that limit drags the Sun's magnetic field behind it as it travels across the solar system. The solar wind moves so fast beyond the Alfvén critical surface that waves inside the wind can't return to the Sun. Until today, scientists were unaware of the exact location of the Alfvén critical surface. Estimates based on remote views of the corona put it between 10 and 20 solar radii, 4.3 to 8.6 million miles from the Sun's surface. The spiral track of the Parker Solar Probe pushes it closer to the Sun with time, and over the several previous trips, it was consistently within 20 solar radii, 93% of Earth's distance from the Sun, theoretically putting it in position to cross the boundary. Parker Solar Probe finally broke through on April 28, 2021, during its 8th flyby of the Sun. Scientists understood the spacecraft had finally entered the solar atmosphere when it encountered the Alfvén critical surface's unique magnetic and particle characteristics at 18.8 solar radii, 8.127 million miles above the solar surface. We should anticipate encountering the corona for at least a brief period of time sooner or later. However, the fact that the solar probe has already arrived there is really thrilling. Parker Solar Probe traveled through a pseudostreamer in the corona as it dipped to barely 14.97 solar radii, 6.4714 million miles from the Sun's surface. During solar eclipses, these huge formations rise like ribbons above the Sun's surface, visible from Earth. It was like gliding into the eye of a hurricane passing through the pseudostreamer. The circumstances quieted inside the pseudostreamer, particles slowed, and the number of switchbacks decreased, a stark contrast to the hectic onslaught of particles that the spacecraft ordinarily faces in the solar wind. For the first time, the spacecraft encountered an area where magnetic fields were strong enough to obstruct particle transport. The particles were trapped at the Sun, proving that the spacecraft had crossed through the Alfvén critical exterior and entered the solar environment, where magnetic fields shape wind to escape. The mission's first corona crossing, which lasted barely a few hours, is the first of several planned. Parker Solar Probe will get as close to the surface as 8.86 solar radii, 3.83 million miles over the next 4 years. Parker Solar Probe will most certainly pass through the corona again during upcoming flybys, the next of which is scheduled for January 2022. It will be mesmerizing to watch what the Parker Solar Probe discovers as it passes through the corona on multiple occasions in the coming years. The possibilities for fresh discoveries are limitless. Solar activity influences the size of the corona as well. The outer border of the corona will expand as the Sun's 11-year activity cycle, the solar cycle, intensifies, giving Parker Solar Probe a sounder chance of dwelling inside the corona for extended periods of time. Some unexpected physics are already emerging. The Parker Solar Probe gathered data during previous encounters that revealed that one location where switchbacks form is on the Sun's visible surface, the photosphere. The solar wind is a constant and tumultuous headwind of particles and magnetic fields by the time it reaches Earth. In another view, the solar wind is organized and patchy as it leaves the Sun. The NASA European Space Agency assignment Ulysses soared over the Sun's poles in the mid-1990s and detected a number of strange S-shaped bends in the magnetic field lines of the solar wind, which detoured charged particles on a zigzag path as they exited the Sun. For decades, scientists believed that these sporadic switchbacks were unique to the Sun's polar regions. However, in 2019, the Parker Solar Probe observed switchbacks in the solar wind at a distance of 34 solar radii from the Sun. This discovery piqued people's curiosities in the characteristics and prompted them to ask additional questions, such as where the switchbacks come from and how they form and evolve. Were they assembled on the Sun's surface or by a process that twisted magnetic fields in the solar atmosphere? The most recent discoveries, which are currently under review, finally confirm that the switchbacks originate near the solar surface. On its sixth flyby, the Parker Solar Probe orbited closer to the Sun, less than 25 solar radii out. Switchbacks are found in patches and have a larger amount of helium, an element thought to come from the photosphere, than other elements, according to the data. When the scientists discovered the patches coincide with magnetic funnels that arise from the photosphere between convection cell formations called supergranules, the origins of the switchbacks were restricted even further. The structure of the switchback regions corresponds to a small magnetic funnel structure at the corona's base. Some theories predict this, and it identifies a source for the solar wind itself. The magnetic funnels are thought to be the genesis of one component of the solar wind and the birthplace of switchbacks. The solar wind is split into two types, slow and fast, and the funnels could be the source of certain particles in the rapid solar wind. Understanding where and how the rapid solar wind components form, as well as whether they're linked to switchbacks, could aid scientists greatly in solving a long-standing solar conundrum of how the corona is heated to millions of degrees. While the new research pinpoints the location of switchbacks, the researchers are unable to confirm how they form. According to one idea, they're caused by plasma waves that sweep around the region like ocean waves. Another theory claims they're formed by an explosive process known as magnetic reconnection, which occurs at the intersections of the magnetic funnels. As the Parker Solar Probe approaches Earth, scientists are looking for more indications now that they know what to look for. As a result of the soon-to-be-released data, scientists will be able to peer into an area that is important for superheating the corona and propelling the solar wind to supersonic speeds. Extreme space weather events, which can disrupt telecommunications and destroy satellites orbiting Earth, will require readings from the corona to comprehend and anticipate. That's it on NASA's Parker Solar Probe touching the Sun. What are your thoughts? Do you think scientists could achieve their dream of getting into the Sun sometime soon? Let us know in the comments below. If this video was insightful for you, then go on and like it. Please kindly subscribe to our channel and click on the bell button for more of our updates.